All right, questions 9 through 11. Let's take a look at this problem now. And we have the friction force pointing up. We have the weight pointing down. We have the applied force to the right. And the wall is going to push back with a normal force. Now this situation is entirely bounced, so we know that the forces bounce in the x and in the y. And so I can write that as the friction bounces the weight, and the applied force bounces the normal. So which force is literally holding the block up? That's the friction force, and we get that from our equation and our free body diagram, one and the same. Now what is the value of the static friction acting on the block? Well, let's figure that out. We know that friction is mu times the normal force. And so we can say that, what is the value of the static friction? So I actually misread. This is a common thing that we do. Sometimes we want coefficient of friction, and sometimes we want the force of friction. We know the friction is equal to the weight from our free body diagram, and so that's going to be 0.5 times 9.8, and I'm going to get 4.9 newtons. Now I can move on and say if the coefficient of static friction to hold is 0.2, we want to know the applied force. So let's use our little bounced equations from this first part here. So we have the friction force equals the weight, which is 4.9 from the previous one. And we also know that the applied force and the normal balance out. So I have friction is mu times n. 4.9 equals 0.2 times the normal force. So I get a normal force of about 24.5. And since we know the normal force has to balance the applied force, we get answer E for the applied force.